Exercise 5.5. Number 2. Y is equal to square root of x minus 1 into x minus 2 divided by x minus 3 x minus 4 into x minus 5. Take log y is equal to log of x minus 1 into x minus 2 divided by x minus 3 x minus 4 x minus 5 to the power half. This is half. Log of a to the power half. It will be half of their product. It will be log of x minus 1 plus log of x minus 2. अब ये तीनों क्या है? नीचे डिवाइड, तो ये माइनस होगा. माइनस ऑफ log of x minus 3 minus of log of x minus 4 minus of log of x minus 5. Now this is a linear form of logarithmic functions. So what we do now, we will differentiate with respect to x. If you differentiate log y, derivative will be 1 by y into dy by dx. Half. For log x minus 1, derivative is 1 by x minus 1 into 1. For x minus 1, derivative is 1 plus 1 by x minus 2 into 1 minus 1 by x minus 3 into 1. Whenever you differentiate any linear equation like x plus k, their derivative is 1 minus 1 by x minus 4 minus 1 by x minus 5. No need to multiply 1 every time. Therefore, your dy by dx is equals to y gets multiplied here, it is y by 2 into 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. This is your solution. You can check the result from NCERT book. This is number 2. Now we'll take number 12. Number 12. X to the power y plus y to the power x is equal to 1. How to find this? Let x to the power y is equal to u and y to the power x is equal to v. Therefore, u plus v is equal to 1. Both are variables. Both are functions of x and y. If you differentiate u, you will get du by dx plus dv by dx. For 1 it is 0. Now how to find du dx and dv dx? So we'll apply the type 3 method. Now u is equal to x to the power y. If you take log u, it will be y into log x. The power is y, it gets multiplied before log x. Now differentiate respect to x. For log u it is 1 by u, and for u it is du by dx. Y into, for log x derivative is 1 by x plus log x multiplied to, for y the derivative is dy by dx. Log x multiplied to dy by dx. Therefore, your du by dx is equals to u into, u gets multiplied on the right side, u is equal to x to the power y into y by x plus log x into dy by dx. This is your du dx. Similarly, if I omit this part, please note it down. Similarly, let v is equal to y to the power x. Take log of v is equal to x times log y. Now differentiate respect to x. For log v it is 1 by v, and for v it is dv by dx. X is u. For log y derivative is 1 by y. For y we have to write dy by dx. Whenever we differentiate a second variable with respect to a first variable, we must mention. Now log y into, for x derivative is 1. Therefore your dv by dx is equals to, v gets multiplied here, it is y to the power x multiplied to x by y dy by dx plus log y. Now we get the values of du dx and dv dx. This is your value of du dx and dv dx. We know that du by dx plus dv dx is equal to 0. Is equal to 0. That's why put the values here. It will be x to the power y into y by x log of x into dy by dx plus y to the power x into x by y dy by dx plus log y is equal to 0. Now collect all the terms involving dy by dx. Here the term contains a dy by dx, another one is here. Now if you apply little bit of algebra, you will get dy by dx into x to the power y into log x plus x into y to the power x minus 1 is equal to x to the power y minus 1 into y plus y to the power x into log y. This is plus, is equal to 0. That's why the value of dy by dx will be is equal to minus of x to the power y minus 1 into y plus y to the power x log y divided by x to the power y log of x plus x into y to the power x minus 1. This is your solution. You can check the result from NCERT solution. Okay. Now we'll solve question number 13. Question is y to the power x is equal to x to the power y. Again, y is a variable, x another variable, x is a variable, y is a variable. Take log on both sides. Log of y to the power x is equal to log of x to the power y. Take log, it will be x into log y plus y into log x. Now differentiate both sides with respect to x. It will be x is u, for log y it is 1 by y into dy by dx plus x into plus log y, x derivative is 1 is equal to y into log x. Y multiplied, for log x derivative is 1 by x plus log x into, if I differentiate y, will get dy by dx. Now collect all the terms involving dy by dx. You will get dy by dx, simple algebraic operation. This is x by y minus log of x is equal to y by x minus log y. Hence your result will be dy by dx is equals to y by x minus log y divided by x by y minus log x. After simple algebraic operations, you will get y into y minus x log y, x into x minus y log x. This is your solution. Number 12. Say 13. Note it down. Next, number 14. Cos x to the power y is equal to cos y to the power x. You can proceed just like number 13. If you take log on both sides, it will be log of cos x whole to the power y. Y is a power, gets multiplied before log cos x. Similarly, x log of cos y. Similarly, if you differentiate both sides, you will get the required result. Again, if you differentiate respect to x, you will get y multiplied to, for log cos x, log of theta, it is 1 by theta cos x. For cos x, derivative is minus sin x plus log of cos x. For y, it is dy by dx. X into log cos y. X is u. If I differentiate cos y, it is 1 by cos y log cos y, and for cos y it is minus sin y. But I have already told you, if I differentiate y respect to x, we must write dy by dx. It is dy by dx plus log cos y into, for x derivative is 1. Just like number 13, if you collect all the terms involving dy by dx in one side and the other terms in the second in the other side, you will get the desired result. I hope you can proceed. This is number 14. Let me show you an extra question. Hash denotes extra question. If you are given x plus y to the power m plus n is equal to x to the power m, y to the power n, you are given find dy by dx, where m and n are both constants, x and y are variables. What will you do? Similarly, take log on both sides. You will get m plus n into log of x plus y. Again, there in the product form, it will be m of log x plus n of log y. Now, we will differentiate both sides with respect to x. M plus n is a constant. M plus n is a constant. If I assume this as a function of x alone, it will be 1 by x plus y. But it is not x, this is x plus y. That's why we will go inside. For x, derivative is 1, and for y it is dy by dx. Similarly, m into, for log x it is 1 by x plus n into 1 by y. For y it is dy by dx. Again, what do? You collect all the terms involving dy by dx. After simple algebraic operation, I will get dy by dx is equal to, you can see, m plus n by x plus y minus n by y, and this is m by x, m plus n by x plus y. If you take LCM on both sides, you will get something like this. If you take LCM, you will get dy by dx into, take LCM, y into x plus y, it is my plus ny minus nx minus ny, m into y, n into y, n into x, n into y, ny cancelled. In the right side, you will get x into x plus y, omit this second step and third step. You will get mx plus my minus mx minus nx. mx cancelled. Your answer will be dy by dx into my minus nx y into x plus y is equal to my minus nx x into x plus y. We can cancel the same terms on both sides. Same. Therefore, your answer will be dy by dx is equal to y by x. This is a good question. Let's proceed. Now, question number 7. Y is equal to log of x to the power x plus x to the power log x. How to differentiate this? Again, we'll apply method type 3 or method 3. We'll put this as u and v. I write this as u, this as v. Both of them are functions of x. Therefore, dy by dx is equals to du by dx plus dv by dx. Name it as 1. Now, if you see, u is equal to log of x whole to the power x. If you take log of u, the power of log x will be a log of, it will be x times log of log x. Now you differentiate u respect to x, you will get 1 by u into du by dx. Proceed, x u into dv dx. For log of x, derivative is 1 by log x, and for log x it is 1 by x, plus now v into log of log x. For x, the derivative is 1. So we get the value of du by dx. We can write, if I omit this part, please note it down. You can write du by dx is equal to, u gets multiplied. U means log of x whole to the power x. Here x and x gets cancelled. It is 1 by log x plus log of log x. This is your du by dx. Similarly, v is equal to x to the power log x. If you take log v, log x is power of x. That's why log x into log x. That is, v is equal to log of x whole square. Now it is log x square. Now there are two functions again. At first is x square. For x square, derivative is twice x, and for log x it is 1 by x. Now if you differentiate with respect to x, you get 1 by v into dv dx. I assume this to be a function of x alone, therefore it is x square. For x square it is twice of x. Your x is log x, and for log x derivative is 1 by x. Therefore dv by dx is equal to x to the power log x into twice log x divided by x. Now if you place the value of dv dx and du dx, the number 1 equation, you will get the desired result. I hope you can start solving other questions like number 6, number 8, number 9. It is not possible to solve all the questions in the class. It is an online class. Okay. Now we'll move forward parametric form of derivative. We can write derivative of parametric functions. I will write functions. What is function? When we can establish a relation between x and y, either in an implicit form or in an explicit form, we call it a function. But sometimes x and y are in relation in terms of a third variable, which is called a parameter. For example, if you are given a circle, x square plus y square is equal to a square, small a square. You can understand from class 11's topic, this is called circle with center at origin and radius a. If I write x equal to a cos theta and y is equal to a sin theta, then it denotes the coordinates of any point lying on the circle. This circle is x square plus y square is equal to a square, where a square denotes its radius and center is at the origin. Now any point lying on this circle is a cos theta, a sin theta. Therefore, I can denote x and y in terms of a third parameter. That means they are in relation in terms of a third variable, which is theta here. A is a constant, theta is a third variable. This is called parameter. When x and y are established in terms of a third variable, then we call it a parametric function. Suppose you are given x is equal to function of t and y is a function of t, where f and g are not same function, they are two different functions. X and y are two different variables, but they are in terms of a common variable t. Therefore, t is a parameter and f and g are functions of t. Now, if you find dx by dt, that is, if I differentiate x in terms of t or with respect of t, we get f dash t. Similarly, if you find dy by dt, you will get g dash t. Hence, if you need to find dy by dx, that is derivative of y with respect to x, we can write the ratio of dy by dt and dx by dt. This dt and this dt get cancelled. Now, what is dy by dt? This is g dash t. And what is dx by dt? This is f dash t. Therefore, it is my dy by dx. Now, the value of dy by dx will also be in terms of t. Clear? In parametric function, what we say? We establish a relation between x and y in terms of a third variable, which is another variable. We call it a parameter. That's why it is called a parametric form. Suppose x and y are two variables which are expressed in terms of t, where t is a parameter, and x and y are two different functions of t, ft and gt. Now, if I differentiate x and y with respect to t, we will get f dash t and g dash t. Hence, we will find dy by dx is equal to the ratio of dy by dt and dx by dt. What is the dy by dt? G dash t, and the value of dx by dt is f dash t. This is the value of dy by dx in terms of the third variable t. This is called parametric function, derivative of parametric function. Okay. Let's move towards exercise 5.6. Derivative of parametric function. Number 1. You are given x equal to twice a t square comma y is equal to a into t to the power 4. X is equal to twice a t square and y is equal to a t to the power 4, where a and a are constants but t is a variable. Now we will differentiate x with respect to t. dx by dt, 2 is a constant, a is a constant. For t square, derivative is twice t. Therefore, it is 4at. Again, differentiate y respect to t. You will get dy by dt, where a is a constant. For t to the power 4, derivative is 4 times t cube, x to the power n, n into x to the power n minus 1. Therefore, your answer will be 4 times a into t cube. Therefore, the value of dy by dx is equal to dy by dt divided by dx by dt. Hence, it is 4at cube divided by 4at. Your answer is t square. The value of dy by dx in terms of t is equal to t square. This is your number 1. Note it down. Now number 2. X equal to a cos theta and y is equal to b cos theta. Now we will differentiate respect to x. Theta. dx by d theta is equal to, for cos theta, derivative is minus sin theta. A into minus sin theta. It is minus a sin theta. Similarly, dy by d theta will be minus of b sin theta. Hence, your dy by dx is equal to dy by d theta dx by d theta. Now, after placing these values, we get minus of b sin theta divided by minus of a sin theta. Sin cancel, minus cancel, it is b by a. This is your value of dy by dx. सिंपल क्वेश्चन. अच्छा अगर भी ये होता, मान लो कि ये एक्स्ट्रा क्वेश्चन है, अगर यहाँ पे भी होता b sin थीटा तो क्या होता? दिस इज द क्वेश्चन. x इक्वल टू a cos थीटा एंड y इज इक्वल टू b sin थीटा. So what does this parametric form represents? Actually, this parametric form represents a ellipse. If you say x square by a square plus y square by b square is equal to 1, then you can say, if I put x equal to a cos theta, it will be a square cos square theta plus b square sin square theta. A square cancel, b square cancel, you are getting cos square plus sin square theta. This is equal to 1. This parametric form will represent the coordinate of a ellipse. Every parametric form represents a function. Number 3, x equal to sin t, sin of t, where t is a parameter, and y is equal to cos twice t, sin t and cos twice t. Now we will differentiate this x and y with respect to t, that is dx by dt. For sin t, derivative is cos t. Similarly, dy by dt will be is equal to, for cos twice t, for cos theta, derivative is minus sin theta. Hence, it is minus of sin twice t. But here it is 2 into t. For twice t, the derivative is 2. You must write 2 into sin twice t. Therefore, your value of dy by dx is equal to ratio of dy by dt and dx by dt. Now place the values. Minus 2 sine twice t divided by cos t. If you can, then simplify it. What is sine twice a? Sine twice a is twice sine a cos a. This minus 2 into twice sine t cos t divided by cos t. Cos t will be minus 4 sine t. If possible, then simplify the solution. If possible. This is your number 3. Number 5. Number 5. X equal to cos theta minus cos twice theta. And y is equal to sin theta minus sin twice theta. Again, x and y are both functions of theta, where theta is the third variable. Now we will differentiate x and y with respect to theta. If you find dx by d theta, you will get, for cos theta derivative is minus sin theta. Again for cos theta derivative is minus sin theta. So minus minus plus, minus sin theta. So plus, for twice theta again derivative is 2. Similarly dy by d theta we can write, for cos theta it is, for sin theta it is cos theta, and again for sin theta it is cos twice theta. But it is twice theta, hence you have to write 2 into cos twice theta. After differentiating x and y with respect to theta, you can find the value of dy by dx as dy by d theta divided by dx by d theta. Parametric form is very simple. You have to just understand the parameter. Therefore answer will be cos theta minus twice cos twice theta divided by 2 sin twice theta, put their respective values, and minus sin theta. This is your value of dy by dx. Number 5. Now number 6. उसे लिख लो, note it down. Now number 6. X equal to a into theta minus sin theta, and y is equal to a into 1 plus cos theta. Now a is a constant, theta is the third variable, that means parameter. Now we will differentiate x with respect to theta. dx by d theta, a is a constant. For theta it is 1. It is like x. ddx of x is 1. Similarly, ddx of dd theta of theta is equal to 1. And for sin theta it is cos theta. Again for dy by d theta you will get small a multiplied 2. For 1 the derivative is 0, and for cos it is minus sin theta. Hence the value of dy by dx is equals to dy by d theta divided by dx by d theta, the ratio of these two values. This is minus a sin theta divided by a into 1 minus cos theta. I have already told you, if possible then simplify it. Now we can simplify this answer as, what is sine theta? Twice sine theta by 2 into cos theta by 2. This is called submultiple angle. And what is 1 minus cos theta? This is twice sine square theta by 2. Hence 2 cancel. Sine theta cancel 1. What is cos by sine? Cot. Cot minus cot theta by 2. This is your required dy by dx in terms of theta. This is number 6. I hope now you people can proceed for number 7, number 8, number 9.